Here's one of those proofs that you might expect will be on the exam on the chapter on differentiation, and that is the fact that the derivative of the general exponential function is equal to the function you started with times the natural log of the base. We already know from section 3.1 in the text how we came about believing that the derivative of e to the x is e to the x. We manufactured a particular exponential derivative that would give us that result. Then the question is, what about if it isn't e? What if it's 2? What if it's 3? What if it's 10? What is the derivative of an exponential with base a to the x? And the answer is, it's just like the derivative of e to the x looks like e to the x, the derivative of a to the x looks a whole lot like a to the x, except there is this little fudge factor there, which is multiplication by some constant. The only case in which the constant is 1 is when it is e, and that would make sense, because if this was e to the x and this was e to the x, this would be the natural log of e, which is 1. So let's see how this proof develops. It's actually based upon a little bit of pre-calculus. The main trick here is you need to write a to the x in a form that allows us to differentiate it. And whereas we don't know how to differentiate a to the x, we do know how to differentiate e to the x or e to something using the chain rule. So if we rewrite a to the x as e to the ln of a to the x, e to the ln of x, you should realize that that is a to the x. So we've transformed this into an e to the a base e derivative. So a to the x, if we use the properties of exponents or of logs and bring the x out as a multiplier, then we can differentiate this using the chain rule. So the derivative of a to the x, differentiated to the right hand side, is derivative of e to the thing is e to the thing times the derivative of the thing, and the thing in this case is x ln of a. The derivative of a constant times x is just the constant. In this case, the constant is ln of x. So that leaves us with the derivative of a to the x being e to the x ln of a times the natural log of a. And then the only thing left to do is to show that this thing can just be replaced, this e x ln of a can be replaced with a to the x. And of course it is just a to the x, because you can see now in step 2 it is a to the x. Therefore the derivative of a to the x is a to the x ln of a, QED.